There is an incendiary weapon infamous for a terrifying property. Once it ignites, it burns through flesh, searing until bare bone is exposed. Because of these horrific effects, its use is heavily restricted under international law. But what is the core element behind this weapon? Surprisingly, it's an element that's absolutely essential to building the DNA inside our very bodies. And the story gets even stranger. It was first discovered by accident when an alchemist was experimenting with human urine in an attempt to create gold. The element behind all of this was phosphorus, element 15 on the periodic table. A seed of life, yet at times a tool of destruction. Today on Dr. Saivera Studio, we're going to explore the fascinating story of this remarkable element. So let's get started. Let's start by looking at how phosphorus was first discovered. The story of phosphorus begins with a rather unusual episode. In 1669, a German alchemist named Heinrich Brandt set out to find a way to make gold, and the material that caught his attention was human urine. He likely chose it because of its color, which resembled gold. What's truly remarkable, however, is the scale of his experiment. Brandt is estimated to have collected about 5,500 liters of urine. It's hard to imagine how he managed to gather such a massive amount. Anyway, Brandt began boiling the collected urine in an attempt to produce gold. But instead of gold, what remained was a mysterious white substance. At this point, the experiment could have easily ended in disappointment, but an unexpected turn changed everything. This white substance had a unique property. It emitted a pale yellowish light and could ignite spontaneously. After observing this, Brandt took inspiration from the Greek word phosphoros, meaning bearer of light, and named the element phosphorus. In other words, as the name suggests, one of its defining characteristics is its high reactivity and its ability to produce light. But this very property also leads to another interesting story. Have you ever heard of strange, unexplained lights appearing in graveyards? People around the world have witnessed this phenomenon, often calling it a will-o'-the-wisp. Interestingly, this isn't just a ghost story. It can actually be explained by science. After a body is buried, decomposition begins and organic matter breaks down, releasing gases such as phosphine. When these gases seep out and come into contact with oxygen in the air, they can ignite on their own, creating flickering flames. In other words, those mysterious lights that once frightened people may simply be the result of a natural chemical reaction. So naturally, this leads to a question. If phosphorus is known for producing light, what other fascinating properties might it have? Phosphorus is a nonmetal element that exists in three primary forms: white, red, and black phosphorus. Let's start with white phosphorus. It is the most basic form of phosphorus. Although phosphorus is found in many phosphate minerals, most industrial production comes from apatite ore. Despite its name, white phosphorus is not perfectly white, but rather a translucent wax-like solid. As mentioned earlier, its most defining characteristics are its extremely high reactivity and its tendency to ignite. In fact, it can spontaneously ignite simply upon contact with oxygen in the air. Because of this, white phosphorus must be stored underwater or in sealed, oxygen-free environments. As a result, strict safety control is essential during transportation. In addition, white phosphorus is highly toxic. Even brief contact with the skin can cause severe damage to the tissue, so it must be handled with great care. Next, let's look at red phosphorus. Red phosphorus is produced by heating white phosphorus to about 250 to 300 degrees Celsius in an oxygen-free environment. Unlike white phosphorus, red phosphorus is stable, does not spontaneously ignite, and is almost non-toxic. Finally, let's move on to black phosphorus. Black phosphorus is typically produced by subjecting white or red phosphorus to high temperatures, around 200 to 600 degrees Celsius, and high pressures, about 1 to 12 gigapascals. As the most stable form of phosphorus, it has low reactivity, does not spontaneously ignite, and is almost non-toxic. Unlike other forms of phosphorus, it also has semiconductor-like properties. So as you can see, these three forms of phosphorus are not just different in color, but also in their properties. So where exactly are they used? First, let's take a look at where white phosphorus is used. As we've discussed, its most defining characteristic is its ability to ignite very easily. This property has been most actively used in the military. Since the mid-19th century, white phosphorus has been used as a key material in incendiary devices and bombs. An incendiary bomb is a weapon that, once ignited, continues to burn using the surrounding oxygen, disabling the target area. White phosphorus is one of the core materials behind these weapons. You may have heard of white phosphorus munitions, often referred to as white phosphorus bombs, which continue to burn once ignited. These weapons are designed to affect wide areas. What makes them particularly dangerous is what happens when they come into contact with human skin. They do not simply burn the surface, they penetrate into the tissue and continue to burn as long as oxygen is present, making them highly destructive. In addition, the phosphorus oxides, P2O5, produced during combustion are highly toxic. Even after a white phosphorus munition has finished burning, any remaining residue can still cause serious environmental contamination. For these reasons, white phosphorus munitions are classified as inhumane weapons, and their use against civilian populations has been strictly restricted under the 1980 Geneva Conventions. While white phosphorus is known for its flammability, its luminescent properties are also widely used. Its ability to emit intense light makes it suitable for illumination rounds and signal flares. The light produced by white phosphorus spreads over a wide area, making it clearly visible from a distance and capable of illuminating surroundings even at night. In addition, when white phosphorus burns, it produces a dense white smoke. This smoke is very thick and does not easily disperse even in windy conditions, making it useful for creating smoke screens. However, because it is highly toxic, its use near civilian areas is strictly restricted. Even during military operations, soldiers must wear protective equipment such as gas masks. Beyond the military, white phosphorus has also been used in various applications. One of its most notable properties is its toxicity, which led to its use as a rodenticide from the late 19th century to the early 20th century. At that time, it was mixed with food or bait to attract rodents. Once ingested, it causes oxidation reactions inside the body, leading to severe damage to internal organs. While it was effective, it was also non-selective. This meant it posed serious risks not only to the targeted rodents, but also to other animals and even humans. As a result, white phosphorus-based pesticides were banned in most countries by the mid-20th century. Now, let's take a look at where red phosphorus is used. Although it's not commonly discussed these days, you've probably seen it many times. You know that red strip on the side of a matchbox where you strike a match? Many people think it's just a kind of sandpaper, but that red material is actually red phosphorus. The head of a match is composed of fuels such as sulfur and carbon, along with oxidizing agents like potassium chlorate. When the match is struck against the red phosphorus strip, the heat generated by friction converts a small amount of red phosphorus into white phosphorus. At that moment, the white phosphorus reacts with oxygen in the air and ignites, which then sets fire to the fuel in the match head. Up to this point, we've mostly focused on phosphorus in terms of ignition and combustion. But interestingly, red phosphorus is also used as a flame retardant. In practice, it's encapsulated and either added to plastics or dispersed throughout the material. When a fire breaks out, red phosphorus reacts to form phosphoric acid, which promotes charring and creates a protective char layer on the surface. This layer blocks heat and oxygen from penetrating further, effectively slowing down the spread of the flame. Considering that phosphorus is usually associated with starting fires, it's a pretty fascinating application. Now finally, let's take a look at the main applications of black phosphorus. While it is not yet widely used in commercial products, black phosphorus is considered a material with strong potential for next-generation technologies. It shows promise in areas such as electronic and optical devices, battery anode materials, biosensors, and advanced materials research. However, there are still significant technical and economic challenges that must be overcome before it can be put into widespread use. Even so, as has often been the case, humanity will find a way to overcome these challenges. Now, looking at the properties of phosphorus we've covered so far, it might seem like a rather intimidating element, almost as if it wants to destroy everything. But interestingly, phosphorus is actually an essential element for all living things. For example, it is a key component of the phosphate groups that form the backbone of DNA and RNA. It plays a crucial role in storing and transmitting genetic information, as well as in protein synthesis. In addition, phosphorus combines with calcium to form calcium phosphate, which makes up our bones and teeth. And phosphorus is just as essential for plants. It helps with energy transfer during photosynthesis and allows plants to use nutrients more efficiently. It also plays an important role in flowering and fruit production. Because of this, phosphorus, typically in the form of phosphates, is widely used in fertilizers. However, when these phosphates are washed out of the soil by rain and flow into rivers and lakes, they can cause a phenomenon known as eutrophication. In other words, excess nutrients enter aquatic environments, leading to the rapid growth of algae and plankton. What's interesting is that phosphorus, an element essential for life and growth, can also become a cause of water pollution. Today we explored the element phosphorus. Its story was unusual from the very beginning. But what's even more interesting is that this element has two completely opposite sides. On one hand, its strong toxicity and ability to ignite can be used to destroy. On the other hand, it plays an essential role in sustaining life. One single element, capable of destroying civilizations, yet essential for creating and sustaining life. What do you think? That's kind of wild, isn't it? That's all for today. I'll be back next time with another interesting story. This has been Dr. Sai Vera.